Institute of Open Schooling, and today we are going to discuss motion in straight line. Before starting the motion in straight line, we must learn about motion. So, motion is a continuous change in the position of the object with respect to observer or any reference point. During the motion, there is a continuous change in the position. It is very important. One, we are taking aeroplane, and there are the four forces acting on the aeroplane which are balancing each other. That is why there is no force which can change the direction of the motion. When object moves without changing the direction of motion, it is called motion in straight line. You can see one example of train moving along the platform, because generally platform are in straight line. So, the motion of the train at the platform is straight line, and there are the few concepts related to the motion or to describe the motion. These concepts are distance, displacement, speed, velocity, average speed, average velocity, and acceleration. When we say distance, it is the length of the path travelled by the object. So, when you want to calculate distance, you have to calculate the length of the path travelled by the object or by the moving object. Displacement is the change in position, that is the difference of final and initial position of the object. Also, you can say that it is the shortest distance between final and initial position of the object. When we say distance and displacement, we must understand the difference between them. Let us take one example. When object moves from position A to B, then to C, now the distance and displacement from A to C can be calculated. So, to calculate distance, we have to calculate length of the path, and to calculate displacement, we have to calculate change in the position of the object. There are the few examples. Here object is moving from A to B, then to C, 10 meter and 8 meter respectively. So, the distance is 10 plus 8, that is 18 meter, and displacement is again 10 plus 8, that is 18 meter. Here object is moving without changing the direction of its motion. And now, second case, object is moving from A to B 20 meter and coming back to C by moving 5 meter. So, distance becomes 20 plus 5, that is 25 meter, and displacement 20 minus 5, that is 15 meter. Another case we can take, that is the third case. Here object is thrown vertically upward to the height of 20 meter, and it is coming back to the same position. So, the distance is 20 upward and 20 downward becomes 40 meter, and displacement is 0, because the final and initial position of the objects are same. Another example, object moves from A to B 8 meter and then B to C 6 meter by making an angle of 90 degree. So, here distance is 8 plus 6, that is 14 meter, and displacement is AC, which can be calculated by applying the Pythagoras theorem, that is square of 8 plus square of 6 and its under root, and 8 becomes equal to 10 meter. Here we have taken these four cases, and on the basis of these four cases, we have to conclude that displacement may be equal to the distance. It is depicted in the first case. Displacement may be less than the distance. It is depicted in second case. Displacement can be 0. It is depicted in third case, and distance cannot be 0, because in all the 4 cases the distance is not equal to 0. However, displacement can be 0. And one thing is very important here,